Fine, cool. No, well, thanks for having you along today. I'll stop sharing my screen and allow you to bring up your presentation then. And yeah, away you go.
I'm already screen sharing.
Yeah, we can see it. Yeah,
brilliant. Good afternoon, everybody. So my name is Lee Broomhall. I work for MBC Timber Frame. We specialise in super insulated houses. From our Passivhaus system to our high performance systems, but everything we do is significantly better than building regs. With this, is just kind of how far down that route you want to go. Historically, our core customer has been the sort of grand design type self builder, because that's historically been the sort of Passivhaus market. It's only really in the sort of recent last couple of years where we've been getting involved in more commercial projects as these have started, going more green. So I'm going to fly through today a little bit about break down our systems in a bit more detail. I'm going to talk through a particular previous MBC Passivhaus project, and I say if anyone's got any questions as we go, really keen to make this as two-way as possible. Just something we had recently, just to share. So one of the things we've gone through over the last 12 months is working with Carbon Neutral Britain. And I think as of April, we're now officially a carbon neutral business. It's something I think that just shows that where we're coming in from a philosophy point of view. We're not just trying to make as much money as we can in this area. We generally believe in what we do, we're generally trying to do it in the right way. So what they do, if anyone doesn't know, is they essentially do a big analysis on our company and all the people that work there, including me working from home and the power to run my laptop. Then they work out how much money we need to commit to carbon saving schemes around the world. So yeah, that's a process we've been through pretty recently. The fancy music, I think. So I won't go spend too much time on this because I'm assuming that everybody's got a good working knowledge of Passivhaus. The reason why I still wanted to keep the slide was from a build systems point of view. Typically, a Passivhaus provider will do more than the average timber frame provider. So one of the things that we sometimes come up against is in comparing quotes. We would always expect to be higher than the average timber frame company because typically we're doing more stuff to tick the relevant Passivhaus boxes. So, the hardest part of building a Passivhaus for my money is passing an air test. Pretty much no timber frame companies will do any air tightness detailing, whereas any Passivhaus provider would. So just what we're generally working for from a legitimate Passivhaus point of view is ticking as many of these boxes from one company as you can. You can have the best wall in the world. If it doesn't talk to your roof properly, it's not going to work from a Passivhaus point of view. And that's why everything that sort of MBC is about taking more control. We want to, if there's an issue, it's our issue, we'll own it, but we want to take responsibility for as much of the project as we can. So, when we're talking about the MBC, even though we're MBC Timber Frame, we're talking about the entire thermal envelope. So that's from the foundation to the walls to the roof and all of the air tightness detailing. The only exception sort of to this is we don't tend to get involved with windows, although we've got lots of partners that we can link people up with. And the main reason why we don't want to get involved with windows unless we have to is it seems to be the biggest single aesthetic choice now on the average project, and we just don't want to tie people down to one particular window supplier. So we've got lots and lots of different people we work with, but we just don't tend to get involved with that process. So once the timber frame has been erected, we then hand over to the client that we put the windows in, and that's when we return to do all the air tightness detailing. So starting from the ground up, so this is our Passivhaus foundation. It's a raft. For anyone that's not familiar with a raft foundation, basic difference is you're insulating below the foundation as opposed to above. So typically, when we're building a foundation in the UK, what we're used to seeing is digging a big hole, filling it with concrete. There's a couple of issues with that. So one of which is concrete is very expensive, and the other is concrete is very, very heavy in terms of carbon. So we like a raft foundation because it uses significantly less concrete. And the difference is, depending on how good the soil is, the difference is made up with hardcore. So if it's really good soil, we'll have 150 mil of hardcore. Then we have some sand binding, and then we have a standard 300 mil of insulation. The insulation, as you can see in the image, is designed at the sides where it'll be like an L shape. And what we're trying to do with the insulation is actually to create the bowl that we're going to pour the concrete in. So we're going to the insulation itself is the form. Now, by insulating underneath and on the outside of the concrete, what it becomes easier to do is to make a connection with the insulation that's in the wall. For me, probably the most difficult junction thermally is wall to floor. And this just means that we can now make a connection with the timber frame. Another benefit of a raft foundation is that you can actually, if you're having enough heating, and it's a passive house, so most, many don't put enough heating in, but if you are having enough heating, you can actually put the enough heating pipe inside the foundation itself. So you literally connect the pipe work to the steel rebar in the foundation, then you pour the concrete straight over the top. And what that means is, we leave the pipe work sticking out the ground. Concrete's a really good, thermal store, your concrete basically, other than your finish, becomes your finished floor. So there's no screed or additional insulation required next. So to see that as a connection, so you can see on the detail on the right. So the red sort of check stuff is that's our insulation. There's 3 layers of EPS. We can make that bigger. So as with any part of our build system, we can make it bigger or smaller as is required by the PHPP. Obviously, passive house is not a fixed U value. So depending on how good the form factor is, all these different things, that dictates how big our wall, floor, and roof is going to be. So 300 mm is standard. We'll often go to 400 if we need to. Also can often be if we've got a lot of structural internal wall. So where you've got a structural internal wall, we'll probably have to remove a layer of EPS to get more steel and concrete in to support that internal wall, and that will impact the PHPP. So sometimes we have to go to a 4th layer of EPS just to sort of fill in them gaps where we might have some structural internal walls. You can see on the left of the detail, we've got an additional external brick footing. What we're seeing now, more and more of, is lightweight external cladding. So whether that's render boards, timber cladding, brick slips, whatever it is, all them things can be hung off the timber frame. Now, we still have a lot of projects where there'll be some masonry. We do a huge amount of work in the Cotswolds. You get a Cotswold stone, whether you want it or not, in the Cotswolds, and that can't be hung off the timber frame. So that's where we have the additional perimeter ring beam, we call it, to build your masonry off that then gets tied into the frame. Someone just asked if you're having the slides after the presentation. Yep, happy to share them. So moving up into the timber frame. So this is showing a 300 mm detail. 300 mm assumes you've got a pretty well-designed passive house. We'll regularly go to 350 or 400, as stated previously, as is required by the PHPP. The insulation that we favour is cellulose, which is made from recycled newspapers and wood fibre and that sort of thing. So it's very, very green, very, very natural. Just depending on how thick we get, it depends upon the U value. So 300 mm is a 0.12 U value, if we go to 400 mm, it's 0.89. In terms of the timber frame itself, it's not a standard timber frame. We've got what's called a twin wall or a Larsen truss. So instead of having one solid stud that goes straight down the wall, we've got like ladders going down the wall. Now, what that means is that when panels connect, I haven't got a cold bridge. Yep. So the insulation can flow between panels. When one wall connects to another wall, the insulation can flow around corners. And that's what we're trying to create, is this continuously insulated thermal envelope. So we find the best way of doing it is with a twin wall. Some people use an I-beam. This is just the way that we prefer that we favour. So whilst we've got a very modern factory and all of these timber frame panels are made off-site and delivered in panels, when they land on site, there is no insulation on them. And that's because the only way we can stop this cold bridging is by blowing the insulation in later. In terms of the actual build-up of materials, so you see the photo on the left, we've got that green board, that's smart ply. So for anyone that doesn't know what smart ply is, it's an air tightness board as opposed to a membrane. We favour a board because we just think it's got more chance of surviving the follow-on trades. Again, for my money, the hardest part of building a passive house is passing the air test. Our biggest concern at that point is that your plumber's going to come and put a hole in it, or someone's going to drag a bit of timber down the wall and have an impact on the air tightness layer. We just think it's got much more chance of surviving. To put the air tightness into perspective, requirement, as I'm sure people know, is 0.6 air changes per hour. We failed an air test once because the client bought the wrong door. When they put the key in the lock, we passed. So when we're talking about air tightness, we're not talking about taking great big holes out of the building. In that example, a keyhole was enough to be the difference in passing a passive house air test. So we're very much an air tightness specialist. Not only do we like to do that, do we do that work? We like to do that work. For us, it's not just passing an air test for the client, but it's checking our own work. We have someone that comes in and does a physical test. The reason why most companies don't like doing air tightness is because you can test for it. It's a pass-fail. The quickest trades on a building site normally is your plasterboarders, because they want to get your plasterboard up before you can kind of see what's going on behind it. My brother lives in a new built house in the Midlands, and I've been telling him for about a year now that part of his house is really cold and it shouldn't be. In the end, I went around his house with a thermal imaging camera, and an entire elevation of his house has no insulation in it whatsoever. And that's generally the practices that we have on building sites in the UK. Now, you know, to be fair to the house builders, they came and fixed it relatively quickly, but he's just fortunate he's got a brother that's in construction. Most people don't. So this is why we like to do things like this, because it just means that we're doing a physical third party is coming in and doing a check. We've even talked about doing the air test ourselves and buying the equipment. We just think it's got more, you know, more credence if it's done by a third party. And that's us saying that, okay, we've now fulfilled our job. We're not really interested in doing electrics, plumbing, plastering, kitchens. We want to take responsibility for the passive house bit, the thermal envelope, and then hand over to follow-on trades to do the remaining works. We'll also typically, as part of our air tightness works, we will fit the service battens. And again, it's just another line of defense against the air tightness membrane. So we've got an air tightness board, and now we've got the service battens, which means there is always something to fix to without worrying about going anywhere near that air tightness layer. On the outside, we have a board which is called Medite Vent, which is a breathable board. It looks like MDF. It's a breathable board. It just means that if moisture ever gets into the wall, it can escape. Yeah, so it just means that we're kind of protecting it for the lifetime of the building. And then we're going to have an additional breather membrane, and that's where we finish. The breather membrane is fixed with like a black tape that tells the cladding people where the stud work is and where they can fix to. But that's the thermal envelope. That's where we finish in terms of the wall. Key bit here is you can see in terms of the twin wall, the inner stud is sitting on the concrete, and the outer stud is sitting on the EPS insulation. Now, all of the structure of the house and the roof is coming down on the inner stud. The outside stud really is just keeping the insulation in. Now, by doing it that way, we can now sort of do the first stage in our continuously insulated shell. So the insulation in the wall actually sits on the insulation that's in the foundation. Yeah, and that's the first part of our thermal envelope. Someone's just, Jason, you've just asked me a question. I don't know the answer to that. I'm going to put that on my list, and I will come back to you when I speak to our air tightness specialist. It's just the way we've always done it. All right, so moving on.
Just before we move on, Lee, just a random question, but in terms of your wall structure, I'm assuming because there's several layers there that the knock-on benefit would also be from a soundproofing perspective as well. Or not? Is that something that? Yeah,
for sure. Well, the key thing is because the insulation is pumped and very dense. Yeah, so we actually have people who complain about it, saying they have to open the windows to hear the birds sing in the morning. You know, so we did a house in Birmingham once because, I mean, the client had no interest in his gas bill whatsoever. It's just the first house you see as you take off from Birmingham International. You just didn't want to hear the planes. Right. You know, so absolutely, especially we did, you know, main roads in London, acoustics. I mean, a lot of the nature of our self-build base is a lot of them are building the countryside. So it's less of an issue for say some companies, but for sure it's very, very positive when you've got 300 mil of continuously densely insulated insulation. So the roof is very, very similar. So we've got a twin wall, which is how we can obviously pump the insulation between studs and between panels. We've got a similar detail in the roof. This is showing a vaulted roof. You know, we can do think truss, raised tie truss, whatever it is. It's as per the drawings. But this becomes a metal web roof, which is like a twin roof. So you probably see metal web joists being used in mid floors. We actually like to form our roofs out of them if we can, because it just means that the insulation can then flow between rafters, and we can stop any cold bridges. Some people don't like the metal in the roof. We get that, so we can replace the metal with OSB. And we have done Passivhaus certified projects with metal in the roof. We're doing one in Edinburgh at the minute. But we understand, metal does have obviously a negative impact on the U value. So we'll kind of, what we try and do is give as many options as we can and work out what the preference is for the particular client. We start off as 400 mil of insulation in the roof, and that gets us to a 0.1 U value. But again, we can make it any size as is required by the PHPP. The really important thing is that when the insulation in the wall gets to the roof, there's no break. It continues. Yeah. So normally you stop your wall, you start your roof, but this is a continuous. But when they're pumping the insulation, we fill up the wall and then we get to the roof. And it means that we've sort of, that's the final part of our continuously insulated shell is water roof, and there's no insulation break there at all. So then you can see it as a complete system. So I talked about the metal web in the roof. You can see there we do use a metal web in the mid-floor. It's also a very, very difficult junction firmly. You know, generally, if you've got a mid-floor joist, you're hanging it off your ground floor and you have a cold bridge at mid-floor level. Because we've got this inner stud, which is our structure, we can top hang the metal web joist off the inner stud and we can still get insulation straight past it. Yeah. So that mid-floor will be a classic cold bridge risk, which we've sort of engineered out. And you can see, you know, the insulation in the foundation talks to the insulation that's in the wall, the insulation in the wall talks to the insulation that's in the roof. And then we have this continuously insulated and airtight house. We have an in-house. Sorry,
I was just wondering, were you just looking at Toby's question there, because he's just asked about the passive. Can the passive wall and foundation detail accommodate differences in floor levels to ground levels?
To a point. Yeah. So if you've got, say, you know, we've got 300 mm of insulation, you know, and then we've got hardcore and sand. Obviously, once you get to a certain level of slope, you need a way of keeping the hardcore in. Yeah. So we do regular. I think our record, the most we've done on a sloping site in terms of keeping it safe and structurally sound is a 500 mm rear to front drop. Beyond that, if you've got to either, you know, dig into the ground and have and find a way of getting your timber frame out of the ground, so whether that's block work or retaining wall detail. But yeah, but the answer is yes, within reason. We also regularly do steps. You know, we've just done a project in Wales where there's quite a significant step on 2 pairs of semi-detached houses, and they're actually quite simple in a raft foundation. So yes. So someone just asked about the insulation being pumped in. So the insulation is, and if they need to replace their tiling later. So the air tightness membrane is obviously below, and so the insulation gets pumped in. So the first thing that we would do when we pump the insulation in is do a density check, and that's to make sure there's no risks of sumping in the future. So we can do density checks. We'll ask the client to choose 1, 2, 5, 10 different places in the house. Then we will do a density check. You can check that against the supplier's guideline, which said if you achieve this level of density, there's no issues with sumping. In terms of, I'm not sure the question here, Jason, if the roof needs replacing. So obviously the roof would be above. You've still got your felt and batten would be a layer. So there shouldn't be any issue with replacing tiling. You know, the materials that are used in terms of the roof build-up will be there for the lifetime of the house. So I'm not sure specifically what you're referring to then.
Did you want to come off? Did you want to come off mute, Jason? No.
We can catch separately, Jason, if you want to have a chat about it. No problems.
Good afternoon. Oh, yeah, right. Sorry. Yeah, if right in the future, can you hear me?
Yep.
Yeah. If in the future, I don't know, 20, 30 years time or whatever the lifespan is, the roof needs replacing, felt battens and everything else, we don't always have a nice, still, sunny day. What's going to happen to the insulation if it's raining? It will get wet. So how's that going to dry out?
So
will it dry?
Well, you wouldn't. If you're replacing the roof, if you're replacing the roof in the case of cellulose, you'd have to put a covering on the roof whilst you're replacing it.
Yeah, because the biggest bugbear of my life at the minute is when you fit PIR, the next morning you go and you end up walking around half the estate picking up pieces of PR that are blown out in the wind.
Yeah, I agree. I used to work for a company that used to use EPS beads, and it's one of them things. Right. Technically, it's great, but if you see the site afterwards, it's just filled with polystyrene beads, and that just cannot be a good thing for the environment. What I will say is cellulose is pretty natural, you know, so it's just from a sustainability point of view, it's pretty good. But yeah, if you were replacing the roof because it's cellulose, you would have to cover it because you can't get it wet.
Right. Okay. Thank you.
No worries. So the design process. So when we say design process, we're talking about the timber frame and the foundation design. Lots of companies outsource this. We want to keep everything in-house. So we have an in-house design team. Many of them are Passivhaus certified designers. The ones that aren't are currently going through it. I think we had two passes last week actually. And so when we're designing a timber frame, we're not just designing a timber frame from a structural point of view, we're designing it from a thermal point of view. how can we get more insulation into the wall, into the roof? You know, if we're using a steel beam here, maybe we can change it to glue lam, so it's not so much of a cold bridge. So we're just looking at it a bit differently to the average sort of timber frame company. And yeah, that's all in house. It's also quite important. A lot of our machinery that we use is CNC machine. So when they're designing the house, they're also making sure they get the right files, which can then be sent down to the CNC machines directly via Bluetooth. And then the guys in the factory just feed it with timber. So it just means it's a lot sharper, a lot smarter process. That's the key thing with timber frame, is that, I always say that, when everyone's watched Grand Designs and they show you these houses that go up in a week, they never show you the 2 months in the drawing office. And that's really where all the magic is. Yeah, the site bits looks really cool. We've got a very fancy factory. If anyone fancies a trip to Gloucester at some point, you're most welcome. But really, all the magic is done in the drawing room. It's done in the design office. If we get any issues later, typically it's something that was missed in design. So we want to spend longer, not shorter, in that process, because it just saves so much time later. The very first part of our process is what we call a pre-design meeting. And that's when we sit down with the client, the architect, anyone else involved in the project, just as a group, and go through the drawings and try and sort of anticipate any questions that our engineer might have, and sort of bring them to the front as opposed to in the back, so that when we're designing it, we can make sure that we've allowed for anything specifically within that building. On a standard sort of development project, it's a lot easier, but our core passive house customer is a self-builder, where we're having to accommodate some weird and wonderful things, whether it's hot tubs on balconies or whatever it might be. So it can be quite an intensive process in terms of design, but we make that quite intensive because it means that the bits that follow are a lot easier. And that's part of our factory. So we've actually just recently trebled the size of our factory. It's a good time to be an eco house provider. The first thing here is, in terms of the factory floor, nothing is cut on the factory floor. What we have is what's called a Hundiger machine. I've got a photo of it. Yeah, we have a Hundiger machine which does all our cutting. Now, this is really important for a couple of reasons. This cuts faster and more accurately than anything else. We don't have the luxury of having terrible tolerances in terms of our cutting. You get a lot of companies which we would call panel bashers. Now, as long as they're close enough in terms of how the timber frame goes together, that's fine. When you're talking about air tightness, that's not acceptable, because we're not just looking at how can the house not blow away in the next 100 years, but how can we make sure that we maintain an acceptable level of air tightness through the lifetime of that build. Now, as buildings move, that's a risk of things like tape coming away. So we just build, all of our cutting is done by machine, because it just means that we're much more accurate in terms of how our buildings come together. That's very good. I tried not to pronounce your name, Ivy. What sort of volumes do you produce? Good question. Well, the first thing is to say is that this increases every year. So as a business, we do about 70 self-build projects every year, and probably about 20 developments. Of all of our work, around about a third of it is passive house, if that gives you an idea.
And when you say 20 developments, how many houses within the 20 developments?
So it could be 25. So we've just done 25 passive houses on Anglesey, and it could be 10. That's our. We very rarely get involved with hundreds and thousands. Sure. It tends to be sort of. I think we've just been appointed for 60 houses for a contractor, which Matt's been dealing with, and that tends to be us. There's a certain level of performance that we won't go below. So often that's probably the difficulty we're dealing with some contractors is there's a point where it's no longer an MBC house, and we just have to say, and actually we our specialty is what we do. There's
also a point, I mean, you say it's a good time to design and build eco houses. Well, it is, but the likes of Ilka Homes is now up for sale, and we were only speaking to Nigel a couple of months ago. There's a number of the modular firms that are struggling, have gone under. So for you to operate at the level you do, it's obviously a bit of a sweet spot.
We've been doing it a lot longer than the average company. I think a lot of the people that have gone haven't been doing it that long. Correct me if I'm wrong. We're sort of 20 odd years in now, so we've kind of a lot of our things in terms of the factory and stuff is paid for. Pretty much any money we make, we reinvest. Our MD was just telling me that the other day that he hasn't taken a penny out of the business. Right. It's the reason why we've got a very modern factory, and we've got the best machinery. around. So, and we're also quite strict in who we work with. Some of the issue with, a good friend of mine used to run a massive timber frame company. It was one of the most successful timber frame companies in the country, and they went bust. The reason why they went bust is because they weren't being paid. And that's sometimes when you deal with these contracts, you've just got to be a bit strict in terms of your terms and stuff, and who you're going to work with, just to make sure that you actually, are sustainable. The biggest issue that people have had and why they're struggling now is material costs. If you're agreeing to do and hold a cost for 2 years, that will send you under now, because there was absolutely no way, if you were pricing work 2 years ago, you can do it for that value today. Whereas we don't guarantee prices for that long.
And then you mentioned the Anglesey project with 25 houses. How are all of those
finished?
identical?
No, I'll show you some pictures at the end.
Cool. Okay.
I was on Anglesey quite recently and visited it. Now they've all moved in. That was a very, very interesting project. But I'll go through that one particularly in a bit more detail. So I'm just going to quickly fly through a actual project in terms of site. So this is a project we did in Bedfordshire. An architect friend of ours called Eco Design Consultants, who do a lot of our Passivhaus certified projects. We would recommend the hell out, by the way. They're really good guys. And this is actually, I think it was the first Passivhaus Plus project in the UK. The reason why it's Passivhaus Plus is basically because of that full amount of solar on the roof. But yeah, this is a very, very efficient house. So you can see here the sort of preparation for a raft foundation. A really big benefit of a raft foundation is you tend to have less digging. Often, actually, we find people not so much digging and just leveling the site. Obviously, you have to sort of subject to soil quality and trees and stuff. But generally, there's a lot less soil being taken out of site. And then we build up the site with compacted hardcore, which they've done there, and now they're getting ready to put the insulation in. So I said you saw the L shape to the part of the out external of the foundation, because we're trying to create a bowl that we're going to put the concrete into later. That goes on top of the sand, as you can see underneath. You want to bring as many services through the foundation as possible. One of the things that we've probably tried hardest, more than anything to do, is to try and say black and white, this is where MBC start and this is where MBC finish. And in terms of services, so whilst we install the foundation, we don't do what we would call site prep. So that's digging the hole. So we'd expect the client to prepare the site. If there's any trees to come out, buildings to come down, whatever it is, and we will tell them what depth to prepare the site to. We also ask them where they can to go a meter outside the footprint of the building. Now, what we will do is we will bring any services out to that meter point. Someone Eva just asked if we've been involved with projects with insulated basements. Well, you can't do timber frame basements. We built off, I believe, an ICF one recently. And there's also a company called Gloucester who have got a very fancy basement system, which I know is pretty popular for Passivhaus. And actually, we've got one. They've not made the decision on NBC yet, but I think we're about to get it, and they're going to be having a Gloucester basement. So we've got some experience, but not lots. Someone also just asked about the scaled. This is potentially something which will need to be scaled quickly for the incoming changes to Scottish energy standards. Yep. It's not just, we do loads of work in Scotland, which is crazy for someone based in Gloucester, but it's really because there's not that many people up there that do Passivhaus. And also there's quite a few architects, actually 2 of which we built their own houses, which do Passivhaus in Scotland that work very closely with us. But it's not just Scotland. We're about to partner up with a social housing provider in Bristol. We hope, we think we're about to. And they're looking at basically changing all their future houses into Passivhaus or close to Passivhaus. The biggest problem that we have in England, which doesn't look like it's going to be the case in Scotland with the new regs, is that they often projects start off as Passivhaus and then slowly get downgraded until the point where they go to site. So we'll often start off talking to a client about a Passivhaus, and then we won't get it, and we'll find out a year later that it was built much more basically. And it's obviously generally due to costs. One of the big things that's helped us lately is the change into regs last year, because the gap between what you can do and Passivhaus has narrowed. So it's not quite the cost increase that it used to be. It still is one for sure, but it's not quite as extravagant as it used to be. And I always say it's not so much the Passivhaus is expensive, it's that you're allowed to build too cheap. And if they just raise the bottom standard, that's the reason why there's so much Passivhaus in other parts of the world. It's because the building regs are so much higher. So if you look in Ireland, the building regs are so much higher. So the gap between what you can do in Ireland and Passivhaus is narrowed. So there's a lot more Passivhaus. And we sort of certainly saw that in June last year when the regs changed. So back to the foundation. So yep, so bring as many services through the foundation as we can. We'll bring them out to that meter point. And you've got your L-shaped insulation on the outside, and then you have 3 layers of EPS underneath. Radon barrier, DPC goes in, and then steel. So we can use a lot less concrete because we've got steel, which is sort of giving the strength to the foundation. Now here you can see that the underfloor heating pipe is being secured to the steel. So this is a certified Passivhaus, but we still see a lot of people that have underfloor heating. It's more of, I always find it's more of a lifestyle thing than a heating thing. Is it? Do you need underfloor heating in a Passivhaus? No, it's a Passivhaus. But some people just like to have that sort of, you know, warm floor to work. I always joke that it becomes the world's most expensive pair of slippers. But yeah, we see probably a significant chunk of our, certainly our self-build customers, where they do put underfloor heating into the Passivhouses. So when it comes to the timber frame, so one of the things that we have to ask people to consider when they're looking at MBC or other offsite manufacturers is that you need a certain level of access. We have to get a lorry somewhere near that site. We need somewhere to park a crane. Now, this is an exaggerated example of a lorry. We use much smaller lorries than this. This is one of the things we ask people to ask quite early in the process is, can you take an offsite manufactured solution? You know, especially, you know, we've got people building in gardens and stuff now, you know, where it can just, we have to sometimes just take a backward step and say, you need to stick build it, you know, and which we don't offer. Everything we do is made in the factory. So we've offloaded here to the foundation, and then you can see the panels, how they come out. That's how they come out the factory. So you can see them twin wall timber frames, but there's no insulation in. Ground floor walls go in. There's that green board. So again, just gives us that strength for the follow-on trades. And there you can see where the insulation is going to go. So that's a glulam beam. So glulam, we are using much more than we've ever used. We have to incorporate some sort of additional structure, whether it's steel or glulam, into the projects that we're doing. Our preference is always glulam. Timber on timber connections are a lot easier. From a carbon point of view, it's much more friendly. The difficulty with glulam is to do what steel does, it will be twice the size. Yeah, so in a lot of cases, it means that, well, if we're going to use glulam, it's going to drop below the plasterboard. Now, some people now are looking for this sort of white, modern internal finish where it just wouldn't work. So we have to go to steel because it's the only way we can still hide the beam inside the floor or the roof zone. But this is an example where the client was quite happy to use glulam. Certified Passivhaus, really, they had no choice. And that's the point where we take the timber frame to, and then we leave site. So once we've got to that stage, so the roof at that stage is structurally it's on, but it's not finished. So we need the client then to take over. Now, what they need to do is they need to put their windows in and their external doors. They need to finish off their roof, whether that's tiling or steel or whatever it is, and they need to put their MVHR ductwork in. Once they ring us up and say, yep, that's done, then we come back, and that's when we do the air tightness detailing. Yeah, and then at that stage, assuming we pass our 0.6 air test, then we've fulfilled our contract. Just to show you some final of that's not a solar tile, that's a solar roof. And this is the finished house. One of the big issues that we have is certainly in terms of the upstairs ductwork is where to put it. So in here, they've decided to make an architectural feature out of it. What we'll often do is put the ductwork inside the rafter zone now. So again, because we've got these metal web rafters, we can put the ductwork in there, or that becomes a problem in terms of Passivhaus. So you wouldn't do that in a certified Passivhaus, which is hence why they've got them here exposed. And there's that glulam beam. So we've used glulam because it's much more efficient thermally, and it, as I say, looks pretty smart. You hear a lot of people seem to sort of default position is oak. And we always tell people, you know, oak is a nightmare to build houses out of. And actually, if you use something like glulam, it still looks pretty good. Just to fly through a couple of projects, I just answered this question. Yep, good point, Kingsley. Absolutely, agree. So this is a project that we did in Wales. So this isn't a certified Passivhaus, and it could never be a certified Passivhaus. And the main reason being is this house is pretty much circular. Obviously, one of the problems with circles and timber frame is that trees are generally pretty straight. So the only way you can get this level of aesthetic is by incorporating an awful lot of steel and an awful lot of glulam. Now, everywhere we've got that steel, everywhere we've got that glulam, is somewhere we can get less insulation. So a lot of the nature of the sort of self-build type projects that we do, the clients have to accept that, and we accept that the aesthetic is often more important than the badge. So that's one of the things that we'll pick up quite early in the process, is just say, you're looking at the certificate, you look at it kind of getting as close as you can to Passivhaus. We've got a Passivhaus system that does not change whether you're getting certified or not. But actually, sometimes there's aesthetic reasons why you couldn't get certified, and this is a big one of them. And there you can see how we've got all these steel beams. It's just going to have a huge impact on the U value to them areas. So this one is a Passivhaus certified project. This is in Norwich, and actually, this the issue that we had here is this is about the most restrictive planning application that I've ever seen. The client wanted to raise their roof by 100 mil, so they can get enough insulation in there to get certified, to which the local authority said absolutely no. But the client was desperate to get this gallery area in. So the only way we could do it was to dig down. So they've this is where you talked earlier about dropping in the foundation. So here you can see a big step in the foundation. Now the only purpose of that step is to make that gallery above, so that we can get enough insulation in the roof to fulfill the PHPP obligations and get certified. This client was adamant she wanted to get certified because I think she'd work. I mean, the cost-wise in this is not a Passivhaus friendly house at all. It was replacing a barn, so that's the way it was facing. We couldn't change it at all, and so it's quite problematic. And so I think it ended up costing her about £150,000 to go through the certification process with the crazy MVHR system she had to have, and all these different things. But she was told by an estate agent it would add like £250,000 to the value of the house. So for her, it's just a no-brainer. And this is another Passivhaus project in Surrey. This is another one that couldn't get certified. It's got a cantilever balcony. Cantilever balconies, there's somewhere you can't get insulation. But the client the cantilever balcony was much more important than the Passivhaus badge. He was adamant he wanted to get that balcony, which is what we've done. But with that, he had to sacrifice going through any Passivhaus certification process. Can someone just tell me they can hear me, because I'm seeing that the the screen froze then for a second. You're back now. Brilliant. This is another Passivhaus project that we did in Kent. And the sole ambition of this particular client was to build a house that didn't require traditional heating. You can see she's got that chimney on the end there. The only heating she has in this house is a log burner. And she texted me in November last year to say she'd used it for the first time. She'd been in the house for quite a few years. So this is a working example. When we say, like, what heating do you need? Well, a lot of it comes down to the character of the people that can live there. And she tells me, if you're the sort of person that will put a jumper on before they mess with the thermostat, then you won't need heating. But apart from on that particular cold period we had last November. And again, this is really just to show that I think a lot of people have an idea of what a Passivhaus looks at in their head. We've built hundreds of Passivhouses. They all look completely different. It's really down to the sort of architectural work. And then finally, so this is the project that we did in Anglesey. This was a first for us, whereas this was 25 social housing, where randomly one day we had a phone call from the builder where the local authority had asked them to look into Passivhaus, and we worked on some costs. It was approved within about a week. I assume they had some money they needed to use pretty quickly before it got to the end of the year. But yeah, so this is 25 social housing built on Anglesey, not certified. But again, we don't change our system whether you are or you're not. There was done PHPP. They reckon they could have certified a lot of them, but some of them they couldn't have done because of size and orientations.
So they're a combination of apartments and houses, or
bungalows, apartments, houses, big mix. Yeah, and this is through an architect we worked with many times. That we've that's big on Passivhaus. I'd never been to Anglesey before I joined MBC. Now I'm there about every 2 weeks. If you look at on our website, we've got a map of all of our projects. They're always in clusters. That's how we get work. One of the things we're pretty crap at is marketing. but we tend to get our work by doing a project, then making friends and doing some more work in that area. That's really why that's kind of one of the reasons for our success, really, is sort of building these networks and one project moving on to others. This concludes my presentation. I'm happy to take any questions.
Cool. Thank you, Lee. Very good indeed. Most interesting. Yeah, I'm interested to hear from the guys on the call, really, to see, why you joined. What did you want to get out of this? Did we answer everything? So if you do have any questions, let us know. So in terms of the way you work, then, Lee, you said you are you the individual house builder? Do they contract you, or do they go to their architect first, who then has that relationship with you? How does someone get to build a passive house with you guys?
It varies. Sometimes we don't meet the architect. Sometimes we don't meet the client. Yeah, sometimes we've got certain architects like Charlie Luxton, who I'm sure people have heard of. We're his sort of passive house provider of choice, and where we just deal with Charlie. But then we've got people where they have found us, and then the only time we ever speak to their architect is possibly on the pre-design meeting. A lot of our sort of one-off builders, they will often consider project managing themselves, whereas maybe they wouldn't have previously, because whilst we're not doing a full turnkey approach, we're doing enough of it where actually the remaining bits become much more viable. If you can save yourself a 10, 15, 20% main contractor fee, that can be quite significant. And actually, that can be one of the ways they pay for their passive house, is by sort of self project management. Essentially, all the dangerous structural bits we're dealing with. It's just trades.
Understand. Jalazy's asked a question there. Did you want to come off mute, Jalazy? Unless you just want to answer it, Lee.
Would you ever consider producing a standardized product, say, for an RP client? What do you mean? I'm not sure what you mean by a standardized product. Do you mean like a MBC house type 1? Standard house types, yeah. We don't tend to. I'm not saying never. It's actually something we have talked about. We may possibly do it at some point, because it can, especially for our developer type customers, where if it's already been designed and engineered, I said like the work that goes in that initial phase, it's big and hence it's costly. So for our developer customers, we have talked about possibly having it where we have these MBC house types that we sort of take to market. For our bespoke customers, not really. And the main reason being is that we work very closely with an awful lot of architects, and we don't want to take work off them. Quite the opposite. If someone comes to us and they're looking at building a house, the first thing we'll ask them is where are they building, and we've worked with this architect. So we prefer to feed work to architects than take work away from architects.
Here's an architect.
Does that make sense?
George is asking a question here.
Yeah, it's a little bit wordy. Hopefully it makes sense.
Less breathable construction. Yeah. So I mean, in an ideal world, George, we just build passive houses. One of the problems that we've got is, well, not a problem. One of the great things we've got is we've got a very, very modern factory, but it's also very expensive to run. So we have the sort of 140 work that goes through it, which is to make sure we've always got work going through the factory. Now, what I will say is our 140 walls are better than the average 140 walls. They still come with air tightness membranes. We favour sticking to a 140 stud. A lot of people now will go to a bigger stud so they can get more insulation in it. But the problem then is you have cold bridges every time you have a stud. So we will stick with a 140 and then add an additional layer of insulation to get the U value, because it stops the studs being cold bridges. How separate is the passive house side of the business? It's not separate really. I do both. Matt, who's also in this call, he does both. What we'll do is we'll present the options to the client and go through the pros and cons and then see which one they choose. So even if it's someone that comes to us for a 140 wall, we'll still give them a passive house price because we want to promote passive house.
How often do you find it goes the other way, where they sort of come initially with the passive house aspiration and then kind of say, is there a way of doing it with 140 studs?
You know what, it's a really interesting point, because it goes both ways. So we'll often have someone that comes to us for a passive house, and then they'll see our 0.11 U value 140 wall. So, well, that's pretty close to passive house, but it's 20 grand cheaper. So we have people that sort of down spec that way, but then we have lots of people where they do it the other way, where they hadn't even considered Passivhaus.
Yeah.
And then when they see our quote and they look into Passivhaus, then they sort of upsell themselves. So we kind of don't want to be too, we don't want to make people feel bad for not going Passivhaus. The fact that they've looked at MBC means they're already looking at going as close as they can within their budget. One of the problems with Passivhaus in general is you typically need a big old wall. For some of our people that are building smaller houses, that can have quite an impact on their internal floor areas. So often we get people that approach us to say, I want to get as close to Passivhaus, but how close can you get me on a narrow profile? When we applaud that because they've got the right mentality, they just can't quite go the whole hog.
Sure. Yeah. Thanks.
And with the standard 140s, in terms of sort of energy usage compared to a bog standard home that you're not providing, what are we looking at there from an EPC perspective and sort of a build's perspective?
I don't know, to be honest with you. We're going to have a load of work on this to publish at some point because we've got some of our clients are doing some work on this. It's one of the things where we know it's pretty good, but we need the bit of paper and the numbers to show you, which we just haven't got yet. So keep a lookout, and we'll be sending something at some point.
Cool, thank you. So you're happy to share this presentation then, Lee?
Yep, no problem still.
Marvelous. Yeah, if you can email it over to me. If there's any more questions from anyone else, I think it was a very, very comprehensive presentation. Again, earlier on, I said it's good to have something technical. It's good to have more of a technical webinar now and again. So yeah, we'll look to see whether we can cover off any other disciplines as well, because I know that you guys always appreciate it. But no, thank you very much, Lee. Thanks for your time. Really, really much appreciate it. Thanks for everyone's questions and comments. It was a great session. So yeah, see you on the call next week. Cheers, guys. Cheers, Lee.
Thank you all. Take care.